Hello?
Good morning.
Morning, how are you?
Okay. I'm finishing breakfast and about to be on the road soon, but I'm checking in for a little bit.
Yeah, yeah, that's good. Waiting for a couple other people. I had a couple people inquire. I think I gave them the wrong time earlier, but uh, I'm going to go through some things. Uh, Actually, some interesting calls for papers, but I'm going to go through everything. I'm going to have it online on YouTube for people who can't make the meeting. So, just to be sure that everyone gets the messages. And we have Ujjwal here. Good. Hello, Ujjwal.
So,
And he's actually interested in one of the calls for papers. So why don't we start? I think Ujjwal has to leave about 10 or 9, in about 30 minutes. So why don't we do that first, and then other people will come in. So let me share my screen. So the first thing is this call for causal data science. Causal data science meeting, which is on Twitter at CDSM20. And this is a standard call for abstracts. This is on the topic of causality, which we've discussed in this group. Causality has long been an important topic in many academic disciplines, such as computer science, epidemiology, philosophy, and economics. In recent years, however, an increasing interest has emerged also in the business sector with experimental and observational causal inference methods. This 2-day online workshop brings together academics and data scientists from industry to share their perspectives on methodological as well as practical aspects of causal inference. And so we can talk about different aspects of causal inference. The workshop will include invited talks and presentation of accepted papers. And then we have different various topics. And then there are going to be some keynotes here. The workshop is November 11th through 12th, 2020. So this is something that is being organized in Europe. Well, it's 1400 to 20 Berlin time, which is in the afternoon, 13 to 19 London time, which is around the same time, and then 8 to 1400 New York time, which is 8 o'clock to 2 o'clock in New York time. So it's if you're in those time zones, that's the time. India time would be several hours later starting. And I don't know if they're going to record the sessions or not. But anyways, the submissions. Please submit your extended abstract 1 page or more, or a complete paper as PDF until October 11 and submit it to this email address. And then if you encounter problems, you can send it to these. Your submission may be work that has been previously presented or is being submitted reviewed elsewhere. So that's the October 11th deadline for that. Now, Ujjwal said that he had some. Hi, Sunidhi. Now, Ujjwal said that he had an idea for that.
Hello, hello.
Yes, it's a little garbled, but
Just a second.
okay.
Better?
Yes.
Yeah, so basically, as the conference website has stated already, we have to do work which is related to causal inference in business studies or in epidemiology or so. One of the idea that we can pursue this year is basically we can try to analyze what would have happened if there is no COVID-19 present on this earth. Like what are the things that has been different in that context if there is no COVID-19. So to do this, we can analyze on multiple perspective, uh, in the stock market, like what would have happened if in the stock market itself, like if there is no COVID-19. And other than that, we can also like do an analysis on different parameters, like what have happened to the travel industry. Like travel industry right now are completely collapsed. So can we do something better on that front, or what will the scene like causal like when we are making a causal inference, there is nothing like you can say which is 100% wrong. Like one can claim like if there is no COVID-19, we might have met some aliens in September 19, but you can't say that this is something 100% wrong when you are working with causal inference. But like as we are not working in fiction and we are working with research projects, so we have to like give some proofs for that, like to support our data hypothesis that we are making. So let me just quickly share my screen once. I have tried to get the summit. Okay, is my screen visible?
Yes.
Yeah. So basically, I have tried to gather some information regarding the stock market exchanges. So Booking.com and Expedia are world leading websites for online travel, which has been collapsed a lot. Like I was following these stocks for around 6 to 8 months, and they have been in a very wild ride. Like Expedia stock has hit the lowest limit of $40, and now they are recovering. But still, the booking data and all these things are not very good in their favor. So what I am trying to do in this case is like we can take a trend from 2019 or 2018 till 2020 January, when the pandemic has just come to this planet, and like it is not being widespread in US, and like it is only contained to China. So to till January, we can take the data and try to extend these trends. Like what would happen in nice 6 to 8 months if the trends are following the way they are. They are not being collapsed by such drastic things. So this is the one thing that I'm trying to do with these two companies. Other than that, these are the stocks of some major big tech uh, firms like Amazon, Apple, and as you can see, there is a very different kind of scenario going here. Like as you have, I don't know, but some may have noticed like Amazon stocks are skyrocketing during this pandemic, as well as Tesla stocks are skyrocketing. So there is something different in tech sector. The tech sector have different like kind of a view when we view it in the COVID-19 context. So same thing that we can do here is as well, like we can predict like if the pandemic has not been on this earth, this Amazon stock still shoots up, because like if you read some articles, you will get to know that Amazon stocks are not something that have to be shoot up like this. This has happened because like more and more people are relied on online shopping now. So people are more investing investors feeling safe to invest on Amazon rather than some tech company who is working directly with the user, like for, for example in hotels and like travel industry. So like some shares are gaining in Netflix. It's the same case study can be happened with Netflix as well. Like Netflix has also skyrocketed because people are like the users have base have been increased by a great margin in this. So this is a kind of proposal that I want to like submit for this uh,
Well, that's
conference.
yeah, that sounds good.
I have a question.
Yeah.
I'm sorry, I don't have the background to this, so I don't know what has been discussed regarding. Shouldn't the trend be similar to what was before this pandemic? Like you're trying to predict if the pandemic had not happened, like what would be the trend? General trend in the
Yeah,
market, right?
yeah. So
In that
basically,
case,
like
shouldn't you get
okay, okay,
something?
okay.
Yeah, just let me. Sorry, but shouldn't you get something like what was already, let's say, the average of last 5 years or something? With, of course,
Uh,
inflation and everything counted in, but shouldn't you get exactly similar trend like what was being observed in the past couple of years or maybe 5 years? No?
Yeah, so basically, like our hypothesis already assumes like trend to be similar, but as I have already mentioned that there are many anomalies in this data. Like Amazon, like if I can just show you. Uh, so, like as you can see in this graph, maybe Amazon is not something which is going on expected lines. It is very, very much on different lines. So this thing has not been happened according to our hypothesis. If pandemic is not there. Similarly, with if you can see with Expedia Group, it has been completely trashed. Like it has hit the biggest low. So this thing can we are like making a hypothesis that this thing might not be happened if the COVID pandemic is not there. So basically, causal inference is something like you predict like what would have happened like if there is no such thing. It might be like COVID-19. You can also like do for 2009 slowdown. Like if there is no slowdown, what would have happened with the world around? And these are just the parameters that I'm focusing on. There might be many parameters which we can extend our research on, like Netflix user database. We can extend on that. World politics we can do on that as well. Like I don't know, like we have to go somewhat fictional in that case, but still we can do on that as well. So yeah, we are like kind of expecting like yes, the trends has to be similar with what is being done in the past 5 or 4 years. But as you can see, there are anomalies due to COVID-19. So sometimes when you are like, if you are a business or account person, you want to know like what if this thing has not happened? Are we doing something wrong? Before COVID-19, for example, if you have followed Expedia Group, they have done a very big layoff in February month when there is no COVID for like in the US at least. So they have done a very big layoff because they are gaining some losses. Like in the quarter 4, they have also experienced severe losses. So there is something wrong going on in that form already. But now with the COVID-19, investors have just dropped its rating from sell and now they are recovering much faster. Like if what my hypothesis believes is if COVID-19 is not there, they are not on $96 right now. They are maybe around 70 or 80 at max. So because of COVID-19, they are still gaining. We know like travel industry has been a lot, but still they are gaining. So this is the kind of causal inference that we are trying to catch here.
So, sorry, just to sum it all up. So, you are trying to predict what would have happened, is it?
Yes,
So, your
yes, yes.
predictions, so your benchmark would be, your prediction should be similar to what exactly the trend was before COVID, is it?
Like in causal, when you are like when you are dealing with causal inference, there is a like kind of a difference when you are dealing with causal inference and statistical inference. So what you are understanding is statistical significance. Like these trend has to be follow these line according to statistics, like according to t-test methods and all these things. But when you are talking about causal inference, it is a bit different. You can't like as I've said earlier, like you can predict anything you want. Like what if happened like if there is no COVID-19, I might have met an alien. No one can say that I'm 100% wrong with that because COVID-19 is there and two things can't happen simultaneously on this earth at least. If COVID-19 is there, so it is there. It is not there, it is not there. So this is the kind of causal inference that we are trying to capture here. Causal inference is all about what if this thing has not happened. So companies like to just to give idea about causal inference. So companies do these things like when they are doing marketing strategies and all these things. So they do think like, what if it happened if we had never made this advertisement? Does it have affected our user base? Or what are the things that are gaining us users? Like a user is reading 3 articles and he is likely to stay with us. But what will happen? He has never read 3 articles. So these are the type of things that causal companies are doing in terms of causal influence. So you can't like really relate statistical influence and causal influence together. Because in statistical influence you have data. Like yes, I have 4 or 5 years data. and I can predict whatever I want to predict through and measure it through t-test and all these things. But when you are working with causal inference, you just have an hypothesis, like I have, like maybe I'm hypothesizing like uh, things were not so good for a particular group and things were not so bad for a particular group as well. And you have to like somewhat support it with the data, whatever data you have. You don't have like much data for that because like we don't have data for the things which are going to happen or which will be happening if there is no COVID-19. There is a COVID-19 on Earth. So that's a major difference between these two, if I'm able to correct it out.
Are you using a specific type of model, or are you just using like how are you determining causality exactly?
So to determine causality, like we can do multiple things. Like first of all, we can do simple regression models just to check like whether what are the trend lines that are going to be there, as well as we have to do some research on like what are the companies' background and what are trends that are going to be happen, like what like if you any one of you follow stocks, or company used to give their EPS measures, like what are their expected estimated per share value is going to be for the next quarters. So we can extract them as well and like try to compare, oh yeah, this thing could have been happened for that. So it is kind of a A/B testing, if you will.
Okay. Any other questions?
Yeah, so I think I still don't get it, but I really am looking forward to your updates on this idea. That might clear it up.
Yeah. Yeah, I think that's
So,
well. Yeah, I think we can.
so the only thing I guess you are confusing between is like statistical inference and the causal inference. So like I know like it's a very minute line between these two, but like in causal inference, to explain it like I need a like hour and so, because like there is a like not very big difference. We both are working on data, but like there is a difference. Oh, if I can put it in the simple terms, like what have happened if things are not happening, like ऐसा क्या था, like uh,
Yeah,
what
I mean, I
happens
get
if
the gist of it, but sorry for interrupting, but I have one question. So, how will you differentiate between whether it's just correlated or they have a causal relationship? Like, because you're going to do regression, right? So, how are you going to determine whether it's just a correlation or a causal relationship?
so according to my hypothesis, I'm trying to get the thing like I'm basically focusing on the company's EPS that they have released before COVID-19 is a thing on this earth. So they had giving their estimates to their shareholders, stakeholders, and all these things to like what we are going to give you on per share. So these are the baseline things that I'm considering. Then I'm seeing like, oh, if this is the thing and this is the trend on which it is going. So is EPS is still matching if there is no COVID-19, or EPS is getting down? Still with like revenue prediction, like many companies, not all companies, give their revenue estimates. Like in the quarter one, we are going to report this kind of revenue. So it is still going on, or there is something going on, like they are not achieving this. So it's a kind of thing, and this is the kind of thing that only related to the stocks we can do. Like COVID-19 has shattered every aspect of life. Like we are like many online classes, meetings, and all these things. So like as soon as we are getting data, we can do many things for causal inference. So to answer your question, yes, the EPS and like predictions of quarterly predictions are the baseline.
So couple of insights, if I may. When the COVID outbreak started, right? So 8 days into the outbreak, I I was in a hackathon in a university, and we were given the task of predicting what is going to be the next number of cases of outbreak. At that point of time, there were only 7 days worth of data, and that was nothing. That was only constrained to the Wuhan region, right? So the challenge which we faced is we had to take into external factors like you are doing currently is stock market signals, and we took in number of flights, the flight routes, and a hell lot of signals from there, right? And we aided put that into the COVID data because that was very minimal, only 7 or 8 data points at that point of time, and we had to predict the next day's outbreak with minimal mean square error. So the problem with stock data is pretty complex. You cannot directly infer a causal relationship or correlate it with a single factor like you're trying to do and with COVID. Uh, and I think that there's the fallacy in what you're trying to do, and it will be very complex if you're looking into EPAs and all of the other factors, because there are many, many hundreds of factors which are affecting those values, not only COVID. So disentangling those factors would be, I guess, would be a real pain. Yeah.
So exactly like you have captured what I'm trying to say is there are multiple factors that are being happening to the stock other than COVID-19. But if you have followed the trend, you can see a sharp decline in almost every tech company around Feb and for March starting. If I may show you,
That's not true. Some tech companies have boomed like hell. Zoom has boomed like
but
hell.
yeah, like
Uh,
Zoom and all these things have boomed, right? But all the companies have faced at least for 2 or 3 days this around this. Like if I can show you the stock of Zoom itself, all companies have faced like all American stock market has shattered in this around this season. If you can see, like they are doing well in March 5, 6, 7, and then they have also a little bit slowed down during the next 2, 3 weeks, and then they again gain up.
that's
Same
an
trend with
event-based trigger. That's a very short-term trigger, and that
yeah.
just shows the
I'm exactly
outbreak into the
focusing
US
on
region.
that yes, because we are basically seeing the US based company. So every company, like if you are seeing Indian stock market, it is around April and May. So
Mhm.
where the COVID has striken, like if you can see,
What is the time frame which you are analyzing the data for? Is it like
sorry
in
for the
months,
internet issue.
years?
So if you can see Netflix stocks and all these stocks as well, they all have shown the similar trend. I guess they have gone down because the US stock market. The time frame I'm taking for like for the pre-period is from 1 year around 2019 or 2018 and to January 1st, and for the post period is like February to till now, till the latest date.
And you're trying to infer slash predict what would be the
Like it is
stock
not
market
something
trend
that
or the various factors. Okay.
Yeah, one thing I think Rishba was
yes, what will be the condition of world economy kind of
uh,
through major stockholders. Like it is not only about
Mhm.
yeah, I think one of the things that Rishba pointed out was that you have these multiple time scales. Well, he mentioned that there are a lot of
I'm
factors,
not
but there
able.
are sort of multiple time scales for things going on. So, like when you say something is causal, is it like a long term trend or is it a short term trend? And then what's the effect on like maybe the next week or
Mhm.
month or year? I mean, because I don't know. Maybe there's maybe COVID is like a single time scale, and maybe you don't want to have too many time scales in there. But you want to be clear when you analyze a data that you're dealing with maybe one or two time scales, or make it clear that there's this period of time that's predicting this other period of time. Just because there's so much going on in the signal that people might say, and they'll ask you, or they'll in the reviews or in the talk or whatever. Well, what about the fact that stocks are volatile and stochastic? It's a stochastic signal, which means that it's there's a lot of sort of randomness in it that affects maybe sometimes how things fluctuate. How do you deal with those things? Um, and I mean, I think that's the method is. I don't know if
So
anyone really has a good method for getting around that. It's just something that people will ask you about.
So basically, if you are asking me like for the short term and long term period, like Netflix, as I have already stated, Netflix, Amazon, Zoom, these are the second part of the tech stocks that have been increased, and the first part is the travel stock that has been decreased. Like trend is very much similar. If you map Booking.com and Expedia, they are while they have very big difference in their valuation and all those things, but the decrease and increase trends are all almost similar. There is no difference. So it means something like if there is a COVID-19 happens in February on US and they are following the similar trend, like they are going down to their bottommost point and then they are up. And like the top bottommost point of Expedia is like $40, which takes the company back to around 6 to 7 years. 6 to 7 years earlier, they have that kind of stock. So it is the biggest hit that they can have in like years, like maybe like kind of a history that they have like made in that short frame. You might not see this kind of trend ever again in the Expedia, like till when the Expedia is active. So this is the type of thing that I'm trying to capture here. Like this thing has still been happened like if COVID-19 is not there. I know like I have like followed the stocks and like I have seen like Expedia is doing not so good before COVID as well. But does this thing has to be like so much low? And now they are around $96. And like I have few people who are working in Expedia. The bookings that they are getting right now is around 5,000 per day, which will in post COVID period is around 100K per day or something. So bookings are not increasing, but the stockholder and the share price are much variable in this. There's some might if you like follow monthly foods and all these websites, so they might told you like Expedia stocks are higher than expected. It are like 2 to 3% higher than what is being expected to them in the last I guess July month. I've read that when they are releasing around their quarterly finance. So this is the kind of thing I'm capturing, trying to capture here.
Well, thank you, Ujjwal, for that presentation. It looks interesting. Next step in doing this is to write it up. If you want to submit it for this workshop, the deadline is in a couple weeks. So if you want to write something up, I would try to, write up a description of what you have in terms of the work, maybe generate some graphs, and then, kind of work out not just like describing the graphs, but also kind of giving some background into the motivation of the problem, which is like the beginning of the paper, the introduction. And then describe your methods and make sure that you are clear. I think Sunidhi's points were good as well, that, make the distinction between, you know, uh, causality and correlation. So, like, you have one of the things about causality is that it's not simply not saying the two things are correlated and that they co-occur. That's not really causality. The idea of causality is that one thing happens because of something else. And, there are a lot of ways that you can deal with that. There are a lot of, well, I think in Neuromatch, a lot of people got exposure to maybe some of the basics of causality and how it's dealt with. And so there's a lot of stuff going on out there. But I think this is a nice empirical case where you can look and maybe, try a method and see if it's, I like the idea of like the scenario building where you say, suppose there was no pandemic or there was no shock to the system, what would have happened? And, you can't really say for sure because there are other things going on all the time that affect life. So, if we hadn't had the pandemic, things may have continued the same way they were going before, but there might have been something else that happened after that. So we don't know exactly, but we can, build these scenarios. And I think that's interesting because, we can, think about alternative paths through the future. And, and that's it's interesting. So yeah, thank you. So I guess now, if you want to submit for the workshop, we have maybe a week or two to put together a draft. So if you could put together a draft and circulate it in maybe about a week and a half or 2 weeks, I think that would be a good timeline. Because you have about, was
Yeah,
it?
sure. So this is not something that I have just started working on. Like I have been working for around a month for a different cause. Like I have explained you in the Slack as well for Make My Trip. I'm working for the Make My Trip. It's like India's giant for online travel, and I'm working for the Causal relations for them. So I guess I can write it out all the things, and I'm trying to say in a talk formally in a half 1.5 week.
That's good. Yeah. Yeah, that sounds good. And then we can take a look once you circulate the draft. And I mean, writing it up is not trivial. Sometimes it takes a bit of work to get things, the references and everything organized, and then the graphs. I think the graphs, it'll be like I'm always a believer in like making really effective graphs. So like you've seen in the DevaWorm meetings where we've talked about different types of graphs and things like that. So try to make them somewhat simple, but also try to be something you can show a lot of information in. So you might have a figure one that's like a schematic where you show the basic idea of what you're trying to do. So maybe,
Yes.
yeah,
Like I will cover all those things. Like this is something that it is like something basic, like data that I have used for pre-table stocks and pre-test stocks are not even normalized. Like they are just the simple representation just to show the trend. So yeah, I will like try to make a good representation of all the things.
okay, very good. Okay, so thank you, Ujjwal. Next order of business is I wanted to introduce Rishabh, who's joining the lab. He's he's going to be working on some things. I just wanted to give him an opportunity to introduce himself.
Yeah, thanks. Appreciate it. So I come from mostly a reinforcement learning and much more recently a neuroscience background. I've been working previously at Dr. Zach Menes' lab in Portugal on distributed data analysis and recently with Dr. Leonard Boragan on connection fingerprinting. So yeah, I'm super excited. Most Some of the projects which are really of interest to me and I believe is a good fit would be like the meta cognition stuff which is going on, as well as the feedback, cognitive feedback loop project, which I believe with my RL and neuroscience background is super interesting to me. I came to know about OREL 6, 7 months back during GSOC. I wanted to apply, but at that point of time, I had some commitments. So now is a good time as ever. So really excited to be with it. I have had chats with Jesse, but not really with anyone else. So looking forward to talking with you guys again.
Thanks for that. You attended Neuromatch as well, of course.
Yeah,
Yeah.
Yeah, glad you're here. I'm kind of like on the road and in transit right now, so I'm not going to be that active this meeting, but I want to say welcome to the lab. And it's good to see everybody else here today too, talking about stuff. So it's good.
awesome. And yeah, really awesome to be talking to you virtually. Finally, we have been mostly talking on Twitter, but anyways, yeah.
Yeah. So yeah, we can talk about what you want to do. We talked about a couple options. There are different things going on in the lab. I guess my philosophy is, wherever you want to contribute, you can contribute. And, there are always opportunities happening. So, we have, for example, we have an NMA Slow Lab starting up. Jesse is working on that. And we have some other research that's going on. Usually, this is the meeting where we hash a lot of that out and we kind of talk about different opportunities, give talks that are, maybe lead to something else, follow up on things. But we also do a lot of stuff in the Slack channels. So if you're, if it's easier for you to work in the Slack channels, by all means you can post ideas, or create a draft and circulate it, or you can give a talk in the group here, or post things in the Slack channel like slides that are maybe describe some idea. I know Jesse and I have posted slides from conferences in the Slack channels, or just the virtual conferences where you have things that you saw that were interesting, and then try to follow up on them. So there are a lot of opportunities like that. And then in terms of a lot of the work of the lab is on GitHub. So we do a lot of stuff in GitHub, and that's where a lot of the things get put together. So welcome. Yeah. So let's see.
Sounds good. Sounds good. It's a bit of backlog on my side. I'll look at some of the work which has been previously done, and I'll start contributing ASAP. It's not an issue at all.
Yeah, it's fine. Also Anson's here and Sunidhi's here. So I didn't say hi, but just make sure to say hi. Let's see if I can share my screen. Yeah. Share my screen again. I wanted to cover some more things here. So we talked about the causal inference workshop, and now this is the thing I made for. I was thinking of ideas for submission for the causal data science, but I don't know if these will fit very well into the causal data science workshop. I was thinking about a couple things. I have this idea of looking at like development, or sort of a big idea of looking at development as a sort of a AI engine, or an engine to analyze data. And so I had a couple things here. That's what these 2 points. Well, this first point was about using some sort of lineage tree structure and a spatial network representing a connectome. So you'd have like some developmental nervous system that would analyze data, and you could build causality into that. And it would be like a description of, how that might work, how you might introduce causality into like an analysis pipeline using a developmentally inspired approach. So this point was pretty raw at the time, but I think I thought it through a little bit more. And then the second point was application of metabrain model, layering as a causal mechanism. So if you're not familiar with the metabrain model, of course, it's in GitHub. We have the metabrain repo, and what the metabrain repo is it's like the idea of layering models on top of models. So you might have a model on the bottom that's like something like a basic perceptron, say, or a neural network even. And that's a connectionist model, and it can do a lot of good things. But then you can put another layer on top of that might be like something that's more of a causal model. And so it would actually evaluate things in terms of counterfactuals, or in terms of which thing came first in a sequence. And so, then you can combine those two, and you can get something that's, this layered processing, where you have, the power of 2 different types of models. So you might have the power of like a neural network and some other model on top of it. And the way it's different from a hybrid model, which we've done, I think we've talked about these before, is that there is this layering aspect. So, it deals with issues like scale, and issues like difference in magnitude, or things like that, difference in type. We've presented this last summer on metabrain models using the developmental Bradenburg vehicles and the contextual geometric structures models. And so those things are juxtaposed in the same model. There are 2 different layers. And so it's a hybrid model, but it's also more than a hybrid model. And so this layering itself might actually be a causal mechanism, or a mechanism to detect causality. Again, I've thought a little bit more about this issue, but I think there's probably a lot more to say about this. The specifics are always what get you, So we can talk more about those. And then, but you know, can we make this in time for some sort of conference or workshop? And I'll talk about that in a minute. And then finally, there's this idea of Gibsonian information. And so I think I mentioned it briefly, but this is an idea that, like, we talked about Shannon information, which is like information of diversity. Gibsonian information then is this idea of using motion cues and multisensory integration to disambiguate things. So, like, if something's moving through the environment, there's information in that movement versus something that's static. And you can use that in data as well. If they talk about, the velocity of data or some other aspect of data where things are moving or the data points are moving at a certain rate. And so you can use those as motion cues, and that can disambiguate a lot of things. And so there might be some interesting hooks there in terms of causality or in terms of other things. So those are all ideas that kind of came out, this week, kind of thinking about like submitting potential papers in this next round of papers post NeuroMatch. Actually, Super NeuroMatch is coming up, so we might actually hook onto one of these ideas for Super NeuroMatch. That's actually probably a pretty good venue if something is fuzzy, we can't quite get enough detail around it. We can maybe submit it to Super NeuroMatch and then do a talk on it, and it'll sharpen things up perhaps a little bit. So those are all like ideas for this submission. Now, this was earlier in the week. I found this call for abstracts, and this is the thing that Ujjwal wanted to present at, or wants to present at, and that's actually his submission might be a better fit for this than the ideas that I mentioned. But this is more. It looks more empirical. But then I found out later in the week that NeurIPS is starting up their registration system. So that's starting up this coming week on the 15th. And so the registration is going to be, it's going to be virtual this year again, or I think virtual this year, because I don't think it was virtual last year. I think it was a hybrid last year. It'll be, I think, $50 for students and $100 for everyone else, which is pretty affordable compared to what it would have been if it were live. And then the great thing about this is, even though the submissions for the main track are closed, they have all of these workshops that are open. Now, not all of them are accepting papers, but there are different opportunities here, both to maybe submit a paper and to look at, or to keep on the schedule. So one of the ones that I found really interesting was this baby mind, how babies learn and how machines can imitate. And this is actually something that Gary Marcus is involved with, and Klaus Obermeier, and a couple other people in machine learning and AI. And this is, of course, a developmental approach to machine learning, or, as they say, what is easy for a baby to learn can be challenging for a human to learn. So babies will learn things that adults may not be able to grasp very easily. So babies don't have to use a lot of processing to learn things like how to walk, or maybe language. But if you're an adult and you're trying to learn a second language, it might be much harder to learn. And so there are a lot of issues with like innateness and the blank slate. And then, later on, there are a lot of issues with like the critical periods of development and other things. So there are a lot of interesting topics that we've talked about in this group that may be covered in this workshop. But I don't think they're accepting any papers. So there was another one that I thought was maybe interesting for some of the ideas I was talking about. And that is, if I can find it, maybe I put a screenshot in here. Oh, I put a couple of possible workshop descriptions in this file. So this is a call for paper. So a couple weeks ago, actually, Jesse posted a call for papers and a workshop for algorithmic fairness. And so that's one of the calls. And the deadline for that is October 5th. Here's the site, afciworkshop.org. And so if you want to, if that's something that you're interested in, you can submit a paper. I don't think we have anything in this group that really fits the bill for this, but it's definitely going to be something interesting to attend. And I think all of the, if you don't want to register for NeurIPS, you can, everyone can, I think, view this stuff later online. So that's always good. So they're going to have breakout sessions and they're going to have papers. It's going to be on algorithmic fairness, which is the idea that, algorithms have to deal with human social life, but they're not really designed for that. So how do you make algorithms more fair or more applicable to the complexities of human societies, especially like a lot of the inequalities that exist in human societies? So you have a lot of different topics here. And so this is the invited speaker list. I'll put a link to this in the chat in a minute. The next one, this is the one I was looking for. Novel Ideas for Training Neural Architectures Workshop. So this actually looks a lot like the Devo NN workshop that we presented at Artificial Life. And so I think it's in the same vein, it's in the same direction. So that might actually be a good place to look at putting the metabrain models idea. So this idea here about metabrain models and layering, maybe not as a causal mechanism so much, but as like a mechanism for learning. That might be a good fit for this Novel Ideas for Training Neural Architectures. There's going to be a lot of stuff on like high-end algorithms, I'm sure. But there's probably room for some really unorthodox approaches, and that's probably where we fit in. So there are things like energy-efficient deep learning, efficient training or inference, neural networks with reconfigurable architectures. So that's close to what we're doing with reconfiguration. Large-scale learning, applications to new domains. So this is a nice workshop. And this one actually is, the deadline for that is the 9th of October. So it's around the same time. Final decisions, 30th of October. And then NeurIPS is in early December. So they want, I think, they never really give really detailed instructions for what they want, but they want a paper. You can submit a paper. They might select some for short oral presentations as well, and then they'll archive the papers on their own in their own system. And okay, so they ask in NeurIPS formatting style. They ask for 4 pages of the main content and an unlimited number of additional pages for the supplemental material, which is so it's like 4 page. You're limited to 4 pages to make your argument and present your data, your main data, and then you can have references and supplemental material after that. But that's something you can work out. So it's doable, I think, in that time frame. And so they want novel papers, and they're going to have a review process. So there's a lot of opportunity there for. Well, let me give you access to this folder here, papers for 9/12. And if you go into here, you'll see this call for papers, NeurIPS workshop. So let me put that in the chat. There you go. And then that's something that we might follow up on. I can generate a draft for that, and then I can circulate it, and people can contribute. And then we can have, we did the paper for Artificial Life, and that was, again, the same thing where I generated a draft, I circulated it, people made comments, added additions, added their ideas, and then we had about 6 or 7 people on as authorship on the paper, and it was a pretty good presentation. We got some pretty good feedback. That's where we ended up getting the critical periods Discord started from those interactions. So it's a nice opportunity, I think. And NeurIPS is always a good conference, especially if you want to get exposed to the wider world of like machine learning and that. So, Rishabh, that might be an interesting opportunity to work towards. Did you have any ideas on that, or?
Yeah, I was looking at the baby minds one, because I know like there are like labs which are only which focus only on learn. So there is the MIT's Child Minds Institute. They only focus on developmental psychology and stuff like that. So if we can translate some of those ideas and introduce a causal mechanism in that one, that would be really interesting, because a lot of work has already been done there in order to understand how babies learn. And even on the machine learning side, there I know there has been some work on grounded NLP, where they see causal relationship between language and actions. So when someone, especially younger person, is told to do something, so what exactly is the process, and how he or she goes about to learn that, or how babies learn from their mistakes and stuff like that. So I think that would be super interesting to look into.
Yeah, definitely. And then we actually have in our in DevoWorm we do a lot of stuff with like developmental biology. So it's a little bit different. It's like you're dealing with the substrate there, but you're still dealing with that whole developmental process. So it's kind of it's people do that approach, but they don't think about it in terms of not necessarily as much in terms of biologically inspired. I've seen this stuff with like how babies learn, and that's a little it's tricky, but it's also very interesting work if you can get it to work right. So that there, I think what I'm saying is there's a lot of opportunity in that area. I think. So.
Yeah, because I believe the bridge between like the psychology side of how babies learn and all of the research which is going on there, and what you guys are trying to do at Evo is have a biologically inspired life form. That there is a huge bridge there, and I think we can adapt some ideas which have already been hypothesized on the psychology side, and see how we can implement it in the development process, which was the first, I believe, the first idea which you wrote down in the GitHub page.
Yeah, yeah. And so, yeah, and also, I don't know if you've read our paper on developmental Bradenberg vehicles.
I have.
Okay, well, I can send it to you. I can put it in the channel.
I have. I read it during
Okay.
Punchy softwares.
Very good. That's good.
Yeah.
Well, that's fine. Yeah. So that's sort of one take on it, and then but we'll talk about it more. So then I guess I'll move on to let's see. I talked about, and let me put the NeurIPS link in the chat as well, so people can peruse that at their leisure. There's a lot of stuff there. So if you find something interesting, you can. As I said, I think it's all going to be available after the conference, so it'll be out there, and there's just a lot of stuff here to go through. So, there's
just to add to the baby workshop. So there are many things that can also be like happen, because like a machine is like not is different from like a baby, like, and we can prove this by uh, training, like, or by differentiating the learning rates between the baby and like in a machine learning model, because like sometimes like as when we are talking in DevOps group, we have stated like when you are doing an image classification, you just pixelate 1 or 2 pixel in the image, and the 99% accuracy model just go like yes, start giving completely wrong results just by altering 1 pixel that can't be even visualized to human eyes. But when we are talking about baby of a human, it is not the case in that scenario. This is the one thing I guess we can give uh, uh, like importance to in our workshop. So
yeah, yeah, like I said, if you have ideas, put them in the Slack channel. I don't know which one you want to make. I don't think we need to make a new one for this because we have a lot of Slack channels proliferating. But we could, find an appropriate one and put it in there if you have an idea that we can follow up on, or because there is opportunities like this. So, all right. So actually, Jesse just had to leave, so I wanted to talk a little bit about his efforts this week on organizing a group. So he's in organizing this cognition discussion group, and this is in Telegram. So this requires an invitation from Jesse, and I think he can give it to you if you ask him. Just ping him in Slack. So this is just like it's like kind of like Slack. It's Telegram. It's a you have the channels, and this channel has a lot of stuff that he's posting on the history of cognitive science. So if that's something, maybe Anson is really interested in it, I think, and probably everyone else. But there's definitely going to be a lot of stuff put in this channel that's like, we'll give you some background on cognitive science and maybe neuroscience. So there's, papers, books that he has access to, some memes that he has access to, kind of like showing, like, this is the ground in which psychology was born. So they have all of these different intellectual founders and things like that. So this is a nice learning opportunity. You can learn about, this is an interesting GitHub repo. So if you want to learn about, a little bit about CogSci and its history and maybe some of the cutting edge, just, subscribe to this and look through it. And I'm sure that you'll find some interesting things here. And so this also is something that is going to tie into a slow NMA, which Jesse mentioned, I think in Slack, but it isn't set in stone when that's going to be. But the idea is that you take the NMA, the neuromatch modules, and you slow them down for everyone. So, neuromatch, like we mentioned before, was sort of like a fire hose. You got exposure to a lot of stuff very quickly. And not all of it was covered in great detail, but the idea is to give people a sampling of things and then they can follow up on them. But it's hard to do that because there's just so many things you find interesting that it's like, you really have to be super motivated to get like, to get everything organized for NMA. So Jesse wants to do the slow NMA where you go through the topics more slowly, digest some of it, and then, maybe follow up on some of the ideas. And so I think he has, if you go into the GitHub repo, there's a GitHub repo for slow NMA. It's in the neuromatch repo of the orthogonal lab Slack, or of the GitHub. And so if you go there, I don't think there's much there yet, but that's where he's going to host that. And then I think this history of cognitive science Telegram is going to link into that because it's going to bring up a lot of these issues. And so I'm very interested to see how Jesse organizes this. He wants to do like meetings like this during the week on different topics, but I'm not really sure how that's going to work out either. But we're in the process of getting that worked out. But anyways, if you're interested, I think some of you are already involved in that. I'm not sure who, but that's an opportunity that's coming up. So that's good. So finally, I'd actually like to present something for about 15 to 20 minutes, and then we'll wrap the meeting up. So as usual, we'll do a presentation. I'll do a presentation here. Let me open it up. So present. Can everyone see my screen? Yes? Okay.
Yep.
All right, thanks. So this is something I've been thinking about, and this is going to be a very loose talk, and it's going to seem a lot, maybe kind of weird to everyone, but it'll maybe make sense by the end, and then we can talk more about this. So this is the idea of observer-dependent models. And so what is it? What does that mean, observer-dependent? So you can think of like a model, like a neural network, or like an agent-based model. And they can be observer-independent, meaning that you can run the model and get a result, and it doesn't matter what the observer is doing. But I think in the agent-based model talk, I discussed the way that they have NetLogo set up. And the way they use NetLogo is they envision NetLogo as like an agent-based model, but that they have a GUI, or a graphical user interface, that is directly manipulated by an observer. And so the observer is modifying the parameters of the model interactively, and it's changing the results of the model in real time. And so then in that case, the observer is actually quite important, because the observer is driving the model in its interpretation. And in fact, if we think about it a little bit, we find that all models are really like that the observer is important because the observer is making an interpretation of the model output. And so it's important for us to consider observers and their effects, and that as part of a model. And so you may know that like in quantum physics, there's this huge debate about observers and observer effects, because a lot of things in quantum theory, there have been a lot of ideas that, observers are sort of fundamental or crucial in the outcome. And so this is from Werner Heisenberg, who's a physicist. This is a paraphrase. The observer registers decisions, which produces a registration, which is a transition from the possible to the actual. So it's like you have all these possibilities, and in quantum theory, there's this idea that there are a lot of different possible states in a wave function, and then it collapses when the observer casts their eyes on it, and it gives you a single outcome. But all outcomes are possible before then. So that observer, in that case, the observer is absolutely necessary and cannot be omitted. But that's sort of an isolated case. That's just one like quantum phenomena, which in a lot of like neuroscience and in the physical world that we live in at the classical scale doesn't necessarily apply. However, we can look to W.R. Ashby from cybernetics, and the second order cybernetics that was developed since Ashby. And in this case, in the second order cybernetics, there's a focus on the role of the observer as an agent. And even in the Evergood regulator theorem, which is Ashby's pet idea, requires an observer to access the full scope of a system's variety. So he doesn't talk about observers directly, but it's an important concept. And so what do we mean by an observer? Well, we have an observer here. We're going to see this icon a couple times here in this talk. This is the observer. And let's suppose that the observer is some sort of brain. It could be like just a small neural network, or it could be like a human brain or something else. And an attentional mechanism, which is this little scope here. And they observe a world, and it's a representation of a world. And it comes through their senses. So there's some of this direct perception of the world. They pay attention to some aspects of it, and then they analyze it in their brain. So this paper by Chris Fields, which is a paper on building the observer into the system. Chris Fields has done a lot of interesting work on the sort of intersection of like biology and neuroscience and physics. And he has this idea that if humans are interacting with the world, we need to have a concept of the observer in a system. If we're going to model the world as a system, we have to have an observer. And a lot of models, of course, don't have an observer. So we have to figure out what that role is. And so in this paper, he asks a couple questions. The first is, how does the observer acquire an object? So I think I've laid out a nice hypothesis here, although this is maybe pretty crude. And then secondly, what information is contained in the world? So this world is a black box. It's just kind of a globe, maybe with some relief, and then, the ocean and some of the continents. So what is the information here? Is this all the information you need, or do you need more? Or can the agent extract all the information on this globe? And that's a question that depends on how, like, does the observer understand that there's a relief on this globe? Like, you see mountains, you see valleys, you see green, and does the agent know what that is, or is it something that can that be interpreted from the model? And so these are things that you ask, but if you ask it from the point of view of the observer, you can get a different set of answers. So this is again a model of the observer in the world, but with feedback this time. So this time, and this is more like what we talk about in the NetLogo case, where this observer is taking in things with direct perception. It's paying attention to certain features over others. It's processing it in the brain, but then it manipulates the world. So now it's not a black box anymore. They can actually manipulate the system, explore the globe, spin the globe around on its axis, maybe cut a piece out of it to see what's inside, assuming that there's a model of the interior geography of the Earth on this globe. Then they can learn about the interior of the planet. So they can do a lot of things like that. And so this is, what if the world is not a black box? And in a lot of systems we observe, they're not black boxes. They have a lot of complexity. This feedback allows us to explore that world, but it also provides a sense of embodiment. That means that you're taking your hands and you're grabbing and manipulating things, and that has a role in how you're interpreting it. But the senses are still a bottleneck, so there's only so much you can learn from that. And that's also important to recognize, because even when we look at data dispassionately, we're often using our senses very heavily. We're heavily relying on those senses to make sense of what we're observing. So I'm going to bring back this roller coaster example from last week's presentation. And this is I like this GIF. I think this gives you an idea of what observer embodiment is. This is where you have an observer sitting in a car on a roller coaster, and the roller coaster is going down the track, and you're getting direct multisensory perception. You're getting visual information, proprioceptive information, and motion cues in the environment. And so all those things are direct experience. And but this is only a representation of a roller coaster. I mean, we're not on a roller coaster. And so we're just kind of like simulating it. And there's a lot of richness and detail in this representation, but it isn't complete. And so this is kind of like a data set, right? Like you have data from the brain, say, and it's an indirect observation, and you create a representation, and then you are in the world of exploring those data, visualizing them, and then getting a handle. You can manipulate it and do all this stuff. I also should have maybe put an image of people who explore protein folding or protein sequences with virtual reality, because that's another good example from the world of data, where you have people who they build these models of protein sequences, which are very complex, and they're high. They have a fair amount of geometric dimensionality to them. So they're these ribbons that curve around, and then you can go into virtual reality and take these proteins modeled as 3D objects, grab them and observe them from different angles, and play with them with your hands or look at them with your eyes. And so then that helps you interpret the data. And so that's true. And so we have to think about the observer not just as like a concept, but actually the physiology of the observer. And so here we have humans and their visual envelope. So if we're using vision to interpret data, we have to realize that there are certain aspects to the visual system, there are constraints on what we can see in our field of view, what we can see around us, and how that relates to the rest of our bodies. So these are just some maps of how we see things. So we don't, see everything around us. We see this cone of, this is the visual limit of the eye. So you can't see everything above you. You have to crane your head. You can see things at the line of sight farther than you can see them in the periphery. and color is a limiting factor as well. So all those things, and we don't, and they seem very trivial to someone who just wants to analyze the data and get out of there. But it's very important when you think about like how we construct reality that that's our limitation as humans. This visual cone, and a lot of what we do is visual, especially with data, and we should recognize this both from like a user perspective of like visualizing data and just like how we observe the world. Then there's this idea of quantum Bayesianism, and the reason I bring this up is because this is an idea of like combining like a model of the observer, so that's the quantum part, with a Bayesian perspective. So in a Bayesian perspective, and all of you who have been in this group a while or went to Neuromatch know what Bayesian models look like. They're these models of having a prior distribution and then modeling subsequent events using that, weighting it by the prior distribution, and then creating a posterior distribution. But in this case, you're doing this in trying to predict quantum states. So you have multiple states that are then evaluated by this observer, and it's so people have thought about this, and it's the reason I bring this model up. It's not to really understand what's going on deeply, but just to understand that this is a kind of model that we're kind of after. And then this, of course, comes from many worlds quantum theory. And so to be clear about what that is, and I mentioned it in the first slide, is that there's this universal wave function that includes all possible outcomes of some world. And then the act of observation makes only one of these outcomes distinct. So I think a lot of people have heard of Schrodinger's cat, where you have this cat in a box, and you don't know whether it's alive or dead unless you actually open the box and look at it. At which point it either is living or dead in the box. And so you observe the final state, but you don't know when it was in the box whether it was alive or dead. And in fact, in the box, in this case, it existed in both states simultaneously. But the act of observing collapsed the states into one outcome. And so this is Hugh Everett, the person who proposed this many worlds theory. And you can see that he exists in different worlds here. But only one of these is the real Hugh Everett. But this actually has implications for perception. And so we know that there's something called multi-stable perception, where you have two different, you have these images sometimes, like this one on the right, where if you look at them, you can see one outcome. And if you look hard again, you can see another outcome. So in this case, this is a bust of a woman where you have the face. If you look at the facial features, you'll see that the face rotates. So it's like it's always facing you. So you can see as it's rotating left and then it's rotating right. But the actual, the shoulders of the bust there's a constant rotation of it. So her shoulders are rotating around an axis, but if you look at the face, you'll see the face, it looks like it's oscillating back and forth between, so that you can always see the facial features. That's a visual illusion. It's actually, the model is rotating around and it's transparent, so you can see all the facial features, front and back, but it actually looks like they're always facing front. And so this is something that is been loosely connected with binocular rivalry. So if you have two eyes and you have, technically you have two fields of vision, but they combine into a single field of vision. But if you cover one eye and you cover the other eye, you can see that they're slightly displaced from one another. And so there's some mechanism of binocular rivalry, and it also involves other brain regions as well. But that's what's basically happening when you look at an image like this and you see this multi-stable aspect to it, where you have these illusions where you have two things. If you look at it, you can see one thing, and then if you look again, you see another thing. But in this case, of course, the observer is very important. And if you think about things that are very complex patterns, we have this issue all the time. And it's not easy to understand exactly what's happening in the brain. People have studied it, like I said, but it's hard to know exactly what's going on. But nevertheless, if you're talking about patterns, you have to think about how we're perceiving the patterns. That's an important part of the analysis. So there are a couple of, in the MetaBrains models repository, there are a couple of different models for this. And I'll go over these really quickly. So in this case, we're looking at something called morphogenetic agents. And so what this is you have an observer and you have an emitter. The emitter will produce a pattern, something we'll call morphogenesis. It could be some striping, it could be some grid pattern that's colored. And then you have an observer who tries to reconstruct the pattern of the emitter using their powers of perception. And so the question is what is the relationship between morphogenesis, the generation of patterns, and perception, the decoding of patterns? And the answer is that one, you can model this as a competitive game. You can do a lot of things, but you can also combine this into a single agent so that every agent can perceive what other agents, and the other agents can produce patterns and perceive other agents. And you can make this link between these sort of shape, pattern formation and attentional mechanisms. And so we can use this in a number of ways. This is an example of where you have the emitter creating the shape, which is like a flag, a tricolor flag, or in this case, a bicolor flag, but it has 3 stripes. And then this agent is trying to figure out what the shape is. So this is, of course, where it doesn't know what the shape is. It's kind of misinterpreting the shape. And in this case, it's made a match on the shape. And so the idea is to look and see how, if you change patterns of this emitter, if the observer can actually recognize it. And if they're the same agent, then, and you have a population of agents, maybe with a similar or the same behavior, then what does that look like? You can also build an adversarial model, which is where you're trying to, say, discover a striping pattern from a bunch of random patterns, and you use the observer then to discriminate between the 2 types of patterns and make a proper classification. And this requires some feedback, of course, but then this results in a binary classification. The other model that we have is our viewpoint networks, and this is something that I've been working on more recently than the other one. And this is where you have these projections, these shape projections, and they're these what they call isometric geometries. So you have this geometric pattern here, which is quite complex, and they have this isometric orientation, which means that they have an equivalent left-right angular orientation. So if you see this line here, this is a straight line. This edge and this edge are at equal angles from this straight line. So you have, it's like a 60-degree divergence to the right and to the left. And so this is actually something they used to use in video games to sort of simulate a 3-dimensional world on a 2-dimensional plane. And so it gives you some information about, and as you know, like if you have like a cube versus a square, you have an extra dimension of information, and you can draw that in 2 dimensions and mimic this. But in an isometric projection, this actually gives you this gives you some added information. And if you build a world like this, it's actually quite rich in terms of information. And so we can use these viewpoint networks, which is that you view this complex shape, and each intersection of an edge in this shape is a node, and that forms a network. And then the agent here, which observes this network at different angles, gives a different interpretation of the network depending on their point of view. So they could be located over here and see one set of patterns, be located over here and see another set of patterns, and so forth. And so if you deploy a population of agents, you can sample this entire geometry. But it also provides you with different versions of the world, or different versions of the truth. And so agent A takes vantage point V, which is here, on a projected geometric object that forms graph G. So this is graph G. And it's just looking at it from a certain angle, reporting back the arrangement of the nodes in terms of their angular displacement. And then that's their viewpoint. And so another agent might take another viewpoint and get different data. And so then you can actually take these separate, or you can average them together, and you can infer sort of the structure of this thing. So this thing is, we can see if we look at it from this vantage point of the way I've set up the model here, it looks three-dimensional, and it looks like tubes that are stacked on top of one another, or cubes that have caves in them, or something like that. So there are a lot of things that we think we see there, but if we have these different viewpoints, we can actually dispel those interpretations, or we can actually find new vantage points that give us new information. And there's something else about these networks, is that we can actually use these visual illusions to our advantage. So we can actually use this information of this appearance of caves as maybe something to encode as information, or encode information into those. And if you can see this from different vantage points, you can interpret the network to have certain properties that it doesn't necessarily have in a two-dimensional. If I just showed you a two-dimensional graph without any of this depth or locational information, you wouldn't be able to encode it in the graph. But if I can see these different visual illusions in this image, then I can actually use that to encode information and view it from a certain perspective. So that's the idea behind this viewpoint networks. And then you can also do this with other types of geometry. So this is interesting. This is something where someone took a Mobius strip and they put Super Mario Brothers on it. They put the Super Mario Brothers world out. They laid it out on this Mobius strip. So it's like the linear world of Super Mario Brothers, but in this continuous curvature. And so again, you can use viewpoint networks to play this game, to view the game, and then to understand its place in the world. But the world is like this continuous curvature. So, you can think of it as like a way to extract information from the sequence of time, even. So you have Super Mario unfolding over time, and you have things going on, and you can actually have different perspectives, not only on space, but on time as well. And so these kind of geometries provide networks with dimensional cues that approximate motion and structural information over time. And so each observer in this case has a unique perspective on the world. Comparisons of different perspectives allow for differential forms of learning and super additive information. And so these are things that we've talked about in terms of the brain, how the brain processes the world in a lot of complex scenes. And so maybe this is a way to get at that a little bit more, and especially in a quantitative perspective. How can we build maybe some AI that learns things in different ways by doing it in this way? So that's all I have there. If you, we're pretty much to the end of our discussion for today, but if you had any questions, I'd be happy to take them.
No questions from my side.
Okay. Okay. Anson, how are you?
Oops, sorry. I thought I muted myself. No questions as of right now.
All right. Well, that's good. Let's see. We have some things in the chat. Okay. Ujjwal had to leave. So it's, well, thank you everyone for attending. That was a good meeting. So the action items then for next time and for maybe a couple weeks from now is that if you have any ideas for papers that we might submit to these conferences, then the deadlines are in a couple weeks, so it's a little tight. Please communicate that on Slack. Also, if we have some, if we want to, I'll circulate a draft of the thing I'm thinking of, and Ujjwal will probably circulate a draft. But if you have any other ideas in terms of directions or conference opportunities, even put them in the Slack. That's always something we're on the lookout for. So I just presented some possibilities, but there are things that are always coming up. So we should get in the habit of that, and then we can target things in that way. Also, I think Sunidhi had some. She mentioned that she had decided that she might try to use the feedback data set for her aging work.
Yeah, so I did suggest that in the last meeting that I attended eventually, but so I did go through that data set and I kind of figured that because I'm really new to it and because like I'd be doing it alone, it's better if I stick with something that I do understand as of now. So I went through that HCP dataset again, which had fMRI time series data for resting state and for some I know for some activities that the subjects did. So I am thinking of exploring that. And Bradley, do you remember that while anime was going on, I mentioned like my pod was trying to find out the differences among males and females during different activities, or let's say even in resting state. So I think I might try to pursue that for a while because in aging dataset I was actually circling around. I didn't get to anything concrete even after 2 weeks. So currently I'm thinking of maybe getting back to that anime dataset. So not just anime dataset, they give very little data points to us. Actually, I checked the HCP website, and there are a lot more subjects to choose from. As in, like the scope of data is a lot more when I access the original HCP dataset. So I think I might explore that and maybe come up with a question as a firm question maybe in the next meeting, and I'll try to take inputs from each one of you whether what I am thinking is viable or not. If it is, I would like to like implement it and maybe go ahead. Yeah.
Yeah, that would be good. I think, like I had mentioned before, I think using a data set you understand is better because you have like
Yeah.
the support that you know what the variables are, and so
Right.
yeah.
Yeah.
So I know for the feedback data set, I think you were. I don't know if you were here for that meeting, but we had a discussion about the variables and what's in the data set. So we have, and I think it's in the GitHub repository, or I also have it in like Google Drive form, where we have the variable names. We have the description of each variable in the feedback data set. So if you want to use that, if you go through the Colab notebook and you run every kernel, you get this process data set. And the process data set, I think, has like 7 or 8 variables in it. And each of those variables has a definition, which we have, so you can know exactly what it is and how it's been measured, which is important when you're doing like, some sort of correlation or some sort of statistical analysis where you want to know like which variable has an effect on what, but you don't know exactly what it means. You can look up the definition and see, because I don't think the variables are particularly straightforward because there's a lot going on in the experiments that they did. Like it was like a mouse that was making a selection on a pattern, and there was like a learning phase, and I can't remember exactly how it was structured, but it wasn't like really straightforward. So I would recommend, if you want to use the feedback data set, that you go through the paper again and make sure that you understand like everything that what they did in the experiment.
Okay, so those Jupyter files you mentioned, they are on the Git link. They are
Oh,
on GitHub.
that there's a GitHub repository.
Okay,
Yeah,
I'll
I
check
can
that.
I can send you the link.
Yeah, please do that. Thank you.
Yeah. All right, and then I think that's it for this week. Thank you for attending, and next week we'll probably follow up on the feedback experiment, and then we'll talk more about the submission, and if anyone has anything they want to mention or bring up during the meeting, it doesn't have to be a really organized presentation. It can be something that's just a topic that they want to talk about, some data. You can bring it. So, bye everyone.